So in this question, let's look at some properties of lines and gradients when it comes to triangles. Now there's two parts to this question. First one is it wants to find the equation of the altitude from the point P. Second one is it wants to calculate the angle that the side PR makes with the positive direction of the x-axis. So there's a few skills that we need to bring in here and a few bits that are involved. One of the big ones is knowing the meaning of the word altitude and the properties that brings into play. So altitude of a triangle, remember, is a straight line from the highest corner to directly to the line opposite that makes a right angle, i.e. is perpendicular with the side it intersects. So what that means is if I looked at my diagram, I could say that the altitude and the line QR are perpendicular to one another. Now it wants the equation of the line. Now remember, the form of the equation of a line is y equals mx plus c. So in order to get it, we either need the gradient and a point, or we need 2 points on the line. Now, on the altitude, I have the point P, I don't have the point where it meets the line QR. If this were a median, I could assume it's the middle of that line and find the midpoint. However, because it's an altitude rather than a median, I can't assume that. You're not allowed to assume things in maths. But what I do know is that because the two lines are perpendicular, the property m1 times m2 equals -1 comes into play. So if I found the gradient of QR and then found out which other number I could take the product of that with to get -1 is, that would then be the gradient of the altitude. So I do that, and then that'll be able to get the equation of that one. So for part A, let's start by finding the gradient of QR. So the gradient of QR, y2 minus y1 over x2 minus x1. So I'm going to do 3 minus 8 over 13 minus -2. So 3 minus 8 is -5. 13 minus -2 is 15. So my gradient is -1/3. What I then do is I use that m1 times m2 property and say, right, so -1/3 times m2, which is the gradient of my altitude, is equal to -1. What that then means is the gradient of my altitude m2 is equal to 3. Now I'm going to take the point that I've got at P, I'm going to take that gradient and I'm going to substitute it into y minus b equals m bracket x minus a. Using this, I can jig it about and get to the format y equals mx plus c. So I'm going to have y minus b, so y minus -1 equals 3 bracket x minus 5. Then it's just a case of playing about with the numbers and getting what we're after. So y plus 1 equals 3x minus 15. Y equals 3x minus 16. That there is the equation of our altitude from P. Now, the second part is calculate the angle that the side PR makes with the positive direction of the x-axis. So what that means is if we imagine I set it up like that and I've got my line PR cutting the x-axis, I want this angle here. Now what I have to remember is I have the relationship m equals tan theta, representing that angle there. So if I find the gradient of PR, I can set that equal to tan theta and then jiggle that about and I can find out the size of my angle. So let's start. So if we do the gradient of PR, what I end up getting for the gradient of PR, same formula, y2 minus y1 over x2 minus x1. I get 3 minus -1, only difference again from that formula is the numbers. Take away, over 13 minus 5. So that ends up giving me 4 over 8. So I end up getting a half. What I can then do is make sure that I know, because of that now, tan theta is equal to a half, is what I'm going to be working with. So from that, I know theta is equal to tan minus 1 of a half, which I can then just enter straight into the calculator. And what I get is that theta is equal to 26.6 degrees, or 0.4636 radians. There's no restriction on the units. It doesn't tell me to use degrees or radians in particular. I can use either version. So I've got two possible solutions depending upon which set of units that I use. So there you go. Questions that bring into play properties of lines, gradients, and relationships between the two of them. This question here, part A is worth 3, part B is worth 2 marks. So for part A, you get 1 mark for finding your first gradient, 2nd mark for using the property of perpendicular gradients to get the second, and then your 3rd mark is for getting the final equation of a line. For part B, you get 1 mark for finding out that the gradient of PR is equal to 1/2, and then your 2nd mark comes in from using the m equals tan theta to get a solution of 26.6 or the 0.4636 radians. For those questions, that's typically a distribution of the marks. So that there, fairly straightforward set of steps. Again, it's all about remembering key phrases like gradient and remembering differences between things like altitudes and medians. If you can remember that, you'll manage a question like this. No problem whatsoever. It'll be easy peasy, lemon squeezy.